today. A couple that you guys will be asked to do with piecewise functions. Graph it. And then also, could you take a piecewise function and write an equation for it? Can you go back and forth with that? Okay. So, start you off with one here. Okay, let's start with something like that. So f of x is defined as x squared on the domain 0 to 2, and it's 4 on the domain 2 to infinity. Okay? So, one thing to check here, this is indeed a function. I made sure. If I had put a bracket around this first 2, and then a bracket around that 2, it wouldn't be a function anymore. Why not? You could potentially have 2 different y values for 1x then, depending. So when I'm at 2, am I looking at the first piece or am I looking at the second piece? I don't know which place to go. Okay. So when you create these things, you have to be careful about making sure that you don't overlap a number. So if it's a parenthesis on one, bracket on the other.
Juniors, please come receive your netbook. Juniors, come to the front main door.
All right, we'll see you guys in a little bit. Okay, to graph this thing, I tried these 2 functions that are inside of this thing fairly straightforward. So, and we're only starting at 0. So this thing is actually all contained within the first. Okay, so from 0 to 2, it's going to look like a parabola. Okay, well when that parabola gets to 2, what value does it have? So it's going to end up here. Okay, and when the parabola is at 0, the beginning of its interval, what's its value? Plug in a 0, what do you get? 0, right, okay. So it's going to be a parabola from 0 to 2, but don't put the arrowhead on the end of it, because it's just a piece. It's not the whole thing, right? That's why we call it a piecewise. We've taken a piece of that parabola and just, we're using that. That's it. Okay? Now, from 2 to infinity, the function has a value of 4. What does f of x equals 4 look like? Yeah, it's just a straight horizontal line of 4. Okay? So, starting here, has a value of 4. Just going to head over. And this one we can put the arrowhead on because it's going to infinity. So that graph would look, yeah, something like that. Is that a continuous function? Yes, it is. Okay. Do the 2 pieces connect? Yes, they do. Okay. Is there any kind of a gap in it at all on any of the 2 pieces? Nope. It's a whole continuous piece of the parabola. It's a continuous piece of that line. They connect up. Yes. Some piecewise functions will not be continuous. There'll be like a jump or a gap or something in between, depending on what we're working with. Okay. So let's try one more. I'll try and make this one a little bit more difficult. and see if we can produce a graph. And then I'll have you go the other direction with it. Okay. So let's do 2 minus x squared for negative infinity to 0, and let's include the 0 on that one. And then we'll do one plus x from 0 to 4. Include the 4 on that one. And then how about negative x plus 9. Yeah, that'll work. Okay, so I got 3 pieces, 2 minus x squared, 1 plus x, negative x plus 9. Each of those individual functions that are kind of embedded in there, you should have an idea of about what those look like. Okay? That's all stuff from what we did in pre-calc last year with basic functions. We got one that's a parabola, 2 that are lines. Okay? And kind of knowing about the properties of each of those to be able to sketch them out. So this one goes a negative infinity to infinity with 3 little chunks that are putting it all together here. So we're going to start with the first piece. And this one will need the whole coordinate plane to do it. All right, so that first piece is from negative infinity to 0. It's going to look like the parabola 2 minus x squared. Okay, so let's at least get like the right endpoint. So at 0, where does that? What's the value of that parabola? 2, right? You plug in a 0, you get 2. So that parabola is going to be here at 2, and that's a bracket, so it will get there. So I'll put a solid dot there. And then what do you know about this parabola if it's 2 minus x squared? So from negative infinity to there, what should it look like? Right, it's a parabola but going down. Okay, it's just the side of it, right? So it's this. And you can put an arrow on the end of that. Okay, that's fine because it's continuing to negative infinity that direction. Okay, so from 0 to 4, it's going to look like 1 plus x. So let's get both sides of that. So if you plug in a 0 into that, what's the value of it? 1. And is it actually getting to that number, though? It's got a parenthesis there, right? So we're going to open circle that one. Because the function at 0 is actually defined on the top piece, right? Not the middle piece. So that's an open circle. Where does that little line segment end up, though? What value? Up at 5. So once we come out to 4, it's supposed to be up at 5. Oops, I got to extend this up a little bit then. Okay, so 4 is going to be over at 5. And that is a solid circle, right? Because that's got a bracket on it. So then we'll connect those together. So it looks like that. And then from 4 to infinity, it's negative x plus 9. So start with the 4 again. If you put a 4 in, what do you get? Okay. So this piece is connected, right? So it's going to start at this point again. And then it's negative x. It has a slope of negative 1 from there. So that's going to come down like that. So, looking at this whole thing, is this a continuous function? Mm-mm. Okay, not all the pieces connect up, right? There's this little gap here between those two pieces, all right? But that's what that graph would look like. Real quick, let's just do one where you have to look at the graph and then write a piecewise for it, and we'll be done. Come on. All right, so say we got that, and then okay, so let's say we got that graph, and we are tasked with coming up with a piecewise defined equation for that. So, first things first, how many pieces do we have? 3. So when we write out our equation, we need to make sure we leave room for 3 pieces. Okay, so the first piece is part of a line. What's the equation of that line that it would be a part of? Be just x, right? What's the slope of that line? 1. What's the y-intercept? 0. So it's just y equals x. So we would just put x. Okay, you don't need the y equals x, because the y equals is already taken care of with this f of x in the front here. So it's just x. Now, we also have to give it a domain, though. What x values is this piece defined for? So from what to what? Exactly. 0 to 2, not including the 2. So like that. That'd be the first piece. Okay. Oh, I guess for this one I better make sure you can see that part clearly. Okay. So second piece, what would be the equation of it? Be just 1, right? Y equals 1. So 1. But again, what's the domain? I think I heard somebody whisper it. What is it? From what to what? 2 to 4. Okay. Do I include the 2? Mm-hmm. Do I include the 4? I can if I want to. I don't though, technically. The 4 has to be included in one of those 2 pieces that connect. Not both, though, right? Just one of them. So, what the heck? We'll do it right now. Okay. So then we can't include the 4 in the last piece, though. Okay. Okay, so the last one is another piece of a line. Okay. What is the slope of the line? -1. So I know I've got negative x, and then what would be the y-intercept? It would be 5, right? Because if you follow that pattern back to the y-axis, it would be up at 5. So it's -x plus 5. Though we never actually see that line cross the y-axis, right? It does have a y-intercept in its equation, but it's just a piece of it, right? So it doesn't actually get there. All right, and then what's the domain for this one? 4 to infinity, but we can't include the 4 because we did in the last piece. Okay, so that would be the equation for that piecewise. Okay. All right, stop there for today. Tomorrow we'll pick up the rest of the stuff. Or not tomorrow. Monday, or actually next week, Wednesday, or whenever it happens to be. But eventually.